Hello and welcome to another lecture on ordinary differential equation, and today we are going to learn about linear differential equation with constant coefficient. So what will be the format of this type of linear equation? So if it is linear differential equation, the format will be something like this: an. Now if the dependent variable is y and the independent variable is x, it will be the nth derivative of y with respect to x, and we'll be getting constants, so this will decrease by 1. Same in denominator, this is the n minus 1th derivative, an minus 2, n minus 2th derivative, and this will go on. Finally we will have an with y equals to q. Now what is the condition for a linear differential equation? It is that y and dy by dx or any derivative must not come in product, and also this any derivative, that means dy by dx must not come in product with d2y by dx square, or you can also say that y must not come in product with any of the derivative. So derivatives must not come in product with each one of them, and y also must not come in product with any of the derivative. So this is the first thing. What is the second basic idea? That the powers of y as well as not only y, any dependent variable, x is the independent variable, then all these rules will be applied for x. So powers of y as well as its derivatives must be 1. So this is the second condition which we will be having, and the basic format remain like this only. So let's get ahead with this. This was the basic idea. Now this is the basic equation, and here, as I have already mentioned, that where an minus 1, an minus 2, so on till an are constants, positive or negative, that depends upon the question, and whatever we have in the right hand side, and q is a function of x, Now please don't remember this. Only thing we have to remember is the basic idea of what is linear differential equation. It may happen that in case x is the dependent variable, so you will get something like d nth derivative of x with respect to y. In that particular case, here you will get a function of y, and here you will get x. So depends on the demand of the question. Now how to find the solution of equations like this? So the solution of the equations like this is in the form of, concentrate here because this will be what you will be writing all across this chapter. So the solution will be CF plus PI. So this is the solution of this differential equation. You will say what is CF and what is PI? So CF is basically the complementary function. CF is basically the complementary function, and PI is our particular integral. So we'll find separately the complementary function, we'll find separately the particular integral, and add them to get our solution. Now one more thing to be taken care of, that we will find the complementary function from the LHS. That means this complete portion will give us the complementary portion. That means if you have to find the complementary function, you only need the LHS of that particular question. And in order to find the particular integral, we need only RHS. So these are two more things to be taken care of. Now, while solving the question, we'll also take care of some of the points which I will be mentioning now. So there are basically 3 points. The first point is the derivative which you see, that means d by dx, then you see d2 by dx square, then we see d3 by dx cube of any function. Then you also see sometime dn by dx power n of some y. So you will have to replace this by capital D. So this is the crux of this linear differential, that you will get format. You may get in this format, which you will be seeing after some time, but for the sake of solving the question, you will always convert this d by dx into d, this d2 by dx square into d square, this into d cube, so on, this as d raised to power n. I don't think in any of the question you will need to write this. Basically up till 4 all the questions are done. Now next we'll see that once we write this, then what will be the format of this particular thing. Now this will become a bit simpler. Now we can write that as an d raised to power n, okay, plus an minus 1 d raised to power n minus 1, so on, plus a0. Now you will say this is only d by dx, where is the y? So you will take a bracket and collectively write y. So when you will bring this y inside, you will get an, this was your d by dx, d ny by dx power n, and a derivative of y. Similarly n minus 1 is derivative of y, and so on. So this will be your format. The RHS was your q and will remain q, and this we write as f of d, because whatever is inside the bracket is can be treated as a function of d into y equals to q. Now this is a short format which we used to write while solving the question, so please take this into consideration as well. Now this was the first step in our question. First step in our question, once you see the question, just do this step. This will be your first step. Now what will be your second step? Second step will be to replace d by m. You will replace whatever times d you will get, you will replace by m, and now this will become a function of m. Now this thing you will replace d by m, and this thing you will equate to 0. You only need this thing. Now forget about y, forget about the RHS, only replace d by m and equate this particular portion to 0. Why? This will look something like this: an m raised to power n plus an minus 1 m raised to power n minus 1, so on up till an equals to 0. And this is your auxiliary equation. So the second step, you will be getting an equation which we know as auxiliary equation, and the roots of this auxiliary equation will move you to the third step. So what is your third step? Your third step is find the roots, and let's say the roots are m equals to m1, m2, m3, so on up till mn, whatever roots you are getting, find that roots. Okay, and now we will have some cases depending on whether the roots are real and distinct, whether the roots are equal, whether the roots are complex. Depending upon that, we will be having cases. But to be starting with basic, this was the basic format of a linear differential equation. This was your method of writing the solution of that particular equation, which is CF plus PI, where CF is complementary function to be evaluated from the LHS. PI is the particular integral to be evaluated from the RHS. Then we saw that once you get your question, you start doing this transformation. You write d by dx as d, d square, d cube, and so on. So you will get this. Now you will place this d by m and equate this to 0. Whatever equation you will get, you will find that roots. Now this must be looking a bit lengthy or more theoretical, but as leave that to me, because when you will solve the question, you will get full confidence and you don't need to remember all this. Just see, and while doing question we will recap, and you don't need to remember. On practicing, it will directly fit into your subconscious mind. So we will now be seeing the cases, the 3 basic cases which will be there, and then after we'll move to the questions where only we'll have complementary function. Because if you have RHS equal to 0, then the particular integral will anyway be 0. So in that particular case, we'll have first phase of question, we'll have only those question in which we need to evaluate complementary function. पहले वही क्वेश्चन को देखेंगे जहाँ पे बस कॉम्प्लीमेंट्री फंक्शन निकालना हो, उसके बाद हम आएंगे पर्टिकुलर इंटीग्रल, उसके बहुत सारे टाइप्स है, उस पे आएंगे. पहले केसेस को देख लेते हैं. सो वी हैव द केस 1. And this is if all the roots are real and distinct. So I'm just writing real and distinct. And when I'm talking about roots are the values of m. So in that case, complementary function will be equal to c1 e power m1x, c2 e power m2x, plus so on, plus cn e power mnx. Now when you are seeing the cases, don't be confused and don't try to remember anything. You can use your notes while solving first few questions, and in gradually you will these things will get into your mind. You don't need to remember. When I first saw this concept, I also was a bit worried as to I will be able to recall this or not, but while solving question it was an easy one. So this was case 1 all about. Now moving to the case number 2. This was real and distinct. Now in case the roots are repeated or equal, let's suppose that m1 equals to m2. These two roots are equal. Now there can be more than 2 roots, only 2 of them being equal and the rest of them being equal to m3, m4, so on up to mn. This might be real and distinct. If there is only 2 root and these 2 are equal, that means same. अब ऐसा भी हो सकता है कि सिर्फ 2 रूट हो और दोनों इक्वल हो, या फिर ऐसा भी हो सकता है 2 से ज़्यादा रूट हो, सिर्फ 2 सेम हो और बाकी डिस्टिंक्ट. तो हम पार्ट्स में फाइंड करते हैं कि कॉम्प्लीमेंट्री फंक्शन इक्वल के लिए क्या हमें ध्यान रखना है. इन केस दे आर इक्वल, स्टार्ट विथ c1, देन कीप ऑन मल्टीप्लाइंग 1x. सो c2 इंटू एक्स. अगर c3 होता, अगर 3 रूट्स इक्वल होते तो c3 इंटू एक्स स्क्वायर, c4 into x cube, c5 into x power 4, so on, and then multiply this by e power mx. Now this m is the equal root. Okay, अब इस केस में we have more than 2 roots, only 2 of them equal, and for other we will apply the case 1. So because these are real and distinct, we will write this as c3, 2 constant, c3 e power m3x plus c4 e power m4x, so on, cn e power mnx. Now one thing, that number of this constant, okay, you need to note that how many constants are there. That is very, very important for any question. So moving to the case number 4. Case number 3, sorry. Case number 3, if roots are complex. Now if only we have 2 roots which are complex, so you always know that roots, complex root always exist in pairs. So if we have first root as m1, second root as m2, and only 2 complex roots, so first of them will be a plus iota b, second will ultimately be a minus iota b. Okay, and let the other roots be m3, m4, and so on till mn. These are your distinct, real, maybe equal also, that doesn't matter because you know how to solve for equal. If this will be equal, you will use this thing. If they are real and distinct, you will use the case 1. Now for this, what we use, the complementary function is, you take a from here, write e power ax, inside bracket you take b from here. Now c1 cos bx plus c2 sin bx, and rest, because these are real and distinct, you will use the case number 1. So you have already used c1 c2, so c3 e power m3 x, c4 e power m4x, so on, cn e power mnx. Okay, so now the final case, if this complex roots are also repeated, so what will be the case in that particular thing? You will have m1 m2, each of them be equal to a plus iota b, and m3 m4 equal to a minus iota b. Okay, so what you will do in that case, you may have other roots also, but concentrate on this. So complementary function in that particular case will be e power ax, you will take a from here, inside, because these are repeating, so c1 plus c2x, consider this repeating case, same here also, c1 plus c2x with cos bx plus c3 plus c4x with sin bx. Okay, and if you have other roots, then we will write similarly while using the first and the second case, and maybe the third one for the other. But for equal and complex root, you will use this thing, this e power ax, c1 plus c2x, c3 plus c4. Now this doesn't depend on a question, this you will have to do. Only the value of b is taken from here, so cos bx and sin bx. So the cases are over now. We will move towards the question part. So let's look at this cases once again, and now we'll be moving towards the problem solving. Now, as mentioned earlier, the first set of problem will have only complementary function to find. So let's write the first question. It says solve, and you have the question as d2y by dx square minus 8 dy by dx plus 15y equals to 0. What was the first step? Replace this in the form of d. So this will be d2. This will be minus 8 times d. And you, from here only take constant and common y. So this y gets multiplied with this. You will get d2y by dx square minus 8 dy by dx plus 15y equals to 0. Second step was convert this d, function of d, into function of m. And only this portion, equate this to 0. This gives you your auxiliary equation. Solve this. M square minus 5m minus 3m plus 15 equals to 0. So you will get m minus 5 minus 3 m minus 5 equals to 0. So you will getting m equals to 5 and m equals to 3. So complementary function is easy. C1 e power, let's see that, say this as m1, this as m2. So e power m1x plus c2 e power m2x. In this case, since the right hand side is 0, so particular integral will be 0. So our solution will be CF plus PI. So basically e power 5x plus c2 e power 3x. This is your solution. Okay. Now let's move to the next question, which is question number 2. We have solved d2y by dx square minus 6 dy by dx plus 9y equals to 0. First step, convert this into format of d. So this is d square minus 6d plus 9 to y equals to 0. Now this d now convert in the form of m. So m square minus 6m plus 9, equate this thing to 0. You can easily find the roots. This is nothing but m minus 3 the whole square equals to 0. From here you are getting m equals to 3 and 3. Now equal roots you are getting, both of them being equal to 3. Now what I told for equal roots, the complementary function will be c1, and with c2 you write one x. If there have been 3 equal roots, let's say 3, 3 and 3, so with c3 you would have written x square, but here only you have 2 multiplied by e power whatever is the root, so e power 3x. And in this case, because the RHS is 0, so particular integral becomes 0. So our solution is CF plus PI. So this is nothing but C1 plus C2x into e power 3x. Okay. So this is the question number 2. Now we will be doing more question in practice session. We are just taking one question at least from its set. So the third question is your d2y by dx square plus 4 dy by dx plus 5y equals to 0. Now this can be written as d2 plus d square plus 4d plus 5, like this. Okay, now in form of m it is like this. Okay, now check the discriminant. It is coming out to be 16 minus 4 into 5. So you're getting minus 4 as the discriminant. So better use that quadratic formula to find the solution. So m you can write as minus b plus minus under root b square minus 4ac, that we found out to be minus 4 by 2a minus 4. This 4 comes out as 2 plus minus 2. Root of minus 1 is iota, as you all know. So minus 2 plus minus iota. Okay, so roots are m1 equals to minus 2 plus iota, m2 is minus 2 minus iota. So a plus iota b. So you are getting a as minus 2, b as now b is not see the sign. What constant is it? Iota, that is a b. So that in this case is 1. So how we write the complementary function in this case? Complementary function is, so you will have only two roots because this is power 2. Now complementary function is e power ax, so e power minus 2x. Okay, c1 e power, now with this you are getting cos bx plus c2 sin bx. So cos b is 1, so simply cos x plus c2 sin bx, so sin x. This is your complementary function, and this will be your solution also, because y is cf plus pi is your solution. So y equals to e power minus 2x c1 cos x plus c2 sin x is your solution also. So please look at this once again. This was a bit different from what we solved earlier. Okay, now coming to the fourth problem. So we need to solve, this is d3y by dx cube plus 4 dy by dx minus 8y equals to 0. Fine. Write in form of d. So d cube minus 2d square plus 4d minus 8 into y. So m cube minus 2m square plus 4m minus 8 equated to 0. Now this is what your equation is. Since this is a cubic equation, so first root hit and trial. So is 1 the first root? 1 minus 2 is minus 1 plus 4. So clearly 1 is not your one root. So is minus 1 the second root, the first root. So minus 1 minus 2. So that will give you minus 3 minus 4 minus 7 minus 8 minus no. So check for 2. So 8 minus 8 0 plus 8 minus 8. Yes, 2 is the first root. So there is one trick. Write the first root here. Okay. Now what we do is write the first root here. Write the coefficient. Coefficient is 1 minus 2 4 and minus 8. Bring 1 0 down, add 1, multiply with 2. 1 by 2. So you're getting 2. Now you're getting 0. Multiply this 0 with this 2. You are getting 0. Add, you are getting 4. 4 into 2 is 8. 0. Now your cubic equation have now been converted into quadratic. Simply multiply by the x square plus 0 into x plus 4 equals to 0. So x square equals to minus 4. X equals to plus minus 2 iota. Okay. So what are your roots in this particular case? Roots are first root being equal to 2. Second root is plus of 2 iota. And third root is minus of 2 iota. Now this 2 iota can be written as 0 plus 2 iota. And this is 0 minus 2 iota. How to write the roots? Sorry, the complementary function. So for this real and distinct, you write like this: c1 e power 2x. Now for complex conjugate, you write like this: take a, so e power 0x, c1 cos of 2x plus c2 sine of 2x. Okay, done. Now you can simplify. You can in place of this e power 0x, you can write 1. So 1 multiplied by this is nothing but simply this thing. So this complementary function in this case, this is special. This will be the value of y also, because y is cf plus pi. Pi is going to be 0. So this becomes your final answer. Coming to question number 5, we need to solve d5y by dx raised to power 5 minus d cube y divided by dx cube equals to 0. So we need to solve this. So in terms of d, if you write this is d raised to power 5 minus d cube into y equals to 0. In form of y, if you write m, if you write this, m power 5 minus m cube equals to 0. Because in auxiliary equation we only need this converted in form of m and equate it to 0. Now how to solve this? Take m cube common. You are getting m square minus 1 equals to 0. Now m cube equals to 0, that means you are getting 3 roots equal to 0. So you are getting m as 0 0 0. These are the 3 equal roots, and from m square equals to 1 you are getting 2 roots. M square equals to 1 will be giving you m as plus minus 1. So plus of 1 and minus of 1. So how to write the complementary function in this case? So these are equal roots. So 3 equal roots. How to write for equal roots? c1 plus c2 into x, c3 increase x power, so x square, with e power whatever is m, so 0 to x. And for other real and distinct, simply now we have come till e c3, so you write c4 e power 1x, simply this, plus c5 e power minus 1x, which is simply this. So I am writing it because our solution is simply y equals to cf plus pi. Pi is anyway 0, so y equals to, this will be your solution. E power 0x is simply 1, so I am writing the final solution as c1 plus c2x, c3x square, c4 e raised to power x plus c5 e raised to power minus x. This becomes your final solution for this question. Now here we have power 5, not power 5. This is the fifth derivative. So we have gone till the fifth derivative. Order is 5 and same is the number of arbitrary constant. You see, this is the main fundamental, that number of arbitrary constant equals to order of the differential equation. So I hope you will keep that in mind also. Now we have some rules for finding the particular integral. Till now we have only solved those differential equation which have RHS as 0, so there we didn't need to find the particular integral because that RHS was 0. You already understand that the particular integral is evaluated from the RHS, and RHS was 0 till now. Now if RHS is some function of x, so then our equation will look something like this: q, where q is some function of x. Now the particular integral, the basic idea is this operator, you will 1 upon f of d into q. This is not the multiplication, you are operating on q, so q is inside, just like we had d by dx of some x square. So you are operating this operator is operating on x square, just like we had x square dx. So this operator, integral operator, is operating on x square. So just like that we have 1 upon fd also, which will operate on q. So rule 1, if q is your e power ax, then particular integral is 1 upon f of a e power ax, provided f of a not equal to 0. Now this thing is very important, provided the denominator is not equal to 0. Now in all the rules which we'll be following from now, if the denominator is equal to 0, what you will do is, if f of a equal to 0, the particular integral will be written as, what you do is you multiply by x. Now write x separately, 1 upon f dash a. How to find f dash a? Now differentiate this with respect to d and then put the value of a, that is f dash a. You will see as we'll proceed with the questions. E power ax, provided f dash a not equal to 0, and if f dash a is equal to 0, how to find the particular integral? You multiply by 1 more x. This x square is again outside. Differentiate it once again with respect to d and then put a, e power ax. Now again, provided that this time this is not equal to 0. Now if this is again equal to 0, you move ahead with the same process. Differentiate it once more, put the value of a, multiply by 1 more x, and so on, till you are getting positive, negative, whatever, but not a 0 denominator. Okay, so let's proceed. Let's solve one question based on this particular rule. So I think we have on question number 6. Question is, solve d square minus 5d plus 6 first thing for the complementary function. So you write this, this is already in the form of d, write this in the form of m for finding complementary function. So m square minus 5m plus 6 m square these are the two. So complementary function we can easily find. c1 e power 2x plus c2 e power 3x. Now coming to the particular integral portion. So what will be the particular integral? 1 upon f of d into whatever is in the RHS, so e power 3x. Now here e power x, a is 3, so you put, now what is f of d? F of d is here, d square minus 5d plus 6. It will be operating on e power 3x. Now if you put 3 here, do it orally. So 9 minus 15 is minus 6 plus 6. So denominator is becoming 0. So what you do is multiply by 1x, differentiate the denominator. You are getting this as 2d. So 2 into, now in place of d put a. So 2 into 3. Now first differentiate. So what you are getting differentiating? So you are getting 2d minus 5. Now in place of d put a. Check whether it is equal to 0 or not. So you are getting 6 minus 5. This time it's fine. Minus 5 e power 3x. So you are getting x by 1 e power 3x as your particular integral. So y is cf plus pi. This will be pi because this is no longer denominator is equal to 0. So this will be your pi. So cf was this. Plus pi x e power 3x. This is your solution. So moving on to question number 7. Question is solve d3y by dx cube minus 3d2y by dx square plus 3 dy by dx minus y equals to e power x plus 2. First of all, we will convert this in form of d. So this will look like d cube minus 3d square plus 3d minus 1 times y. Now to find the complementary function, write this in form of m. So m cube minus 3m square plus 3m minus 1 equals to 0. Is 1 a root? So 1 minus 3, that will be minus 2 plus 3. That is 1 minus 1, 0. Yes, 1 is 1 root. So write 1 here. Now, write the coefficient of this cubic equation. So it is 1, minus 3, 3 and minus 1. Now write 0 here. Add 1, multiply 1. Multiply with 1 into 1 is 1. Write that 1 here. Add again. Minus 2. Multiply. Minus 2. 1. Multiply. You will get 1. Finally 0. Now what was a cubic equation has now been converted into a quadratic equation. M square minus 2m plus 1 equals to 0. So this is m minus 1 whole square equals to 0. So this will give us two values as equal, m as 1 and 1. So finally we have the three values of m, which is 1, 1 and 1. Okay. If you have seen this carefully, this was just a cubic, a very easy one, m minus 1 the whole cube. But anyway, we got to the answer. You would have directly written from here m minus 1 the whole cube and got the three roots as 1, 1 and 1. Now, once we have got the three roots, we'll use find the complementary function, for which we know the rule that c1 plus c2 times x, because it is equal, c3 times x square, and with that you write e power mx. So e power 1x, which is this. Now for particular integral 1 upon f of d into whatever is in the RHS e power x plus 2. Okay. Now what is f of d? It is this. So I will write that 1 upon d cube minus 3d square plus 3d minus 1 times e power x plus 2. Now I will separate, so I will write this as 1 upon d cube minus 3d square plus 3d minus 1 ex plus 1 upon d cube minus 3d square plus 3d minus 1 times 2. Now I can send this 2 out since this is a constant. So this comes out here out of this operator, and inside I am left with 1, which I can write as e power 0x. Okay. Now I know the formula for this, I know the approach for this and this both, because first of all you will put the coefficient of x here, so it is 1 minus 3 minus 2 plus 3, that is 1 minus 1 0. Since it is 0, so you will multiply by 1x, keep it separate and find the derivative of the denominator, so that is 3d square minus 6d plus 3. Now again put 1 here, so 3 minus 6 minus 3 plus 3, so this is coming out to be again 0, so multiply by 1 more x, so write this like this, so multiplying by 1 more x you get x square, again the derivative, that will give you 6d minus 6 e raised to power x. Now check, so if you put 1 here, so it will be 6 minus 6, again 0, so multiply by 1 more x, differentiate, so this time you will get only 6 e power x, so this becomes your final. Coming to this one, so put 0 here, 0 0 0, just minus 1, so minus 1 by 2 is what you are getting from this side, and this is your collective particular integral. So if I were to write the solution, I will write CF plus PI. CF is this, C1 plus C2x plus C3x square and plus x cube e power x by 6 minus 1 by 2. So let's see this once again. It was a simple question. We just did this was, I think, the waste step, because this was directly m minus 1 the whole cube. Here also you would have written d minus 1 the whole cube, and that way it would have simplified. This was becoming 0, so differentiated here. It was just, if you put 0 here, you will get 0 0 0 and minus 1, so it was 2 by minus 1. Okay, so this will be minus 2 only, minus 2. So there was a big mistake, minus 2. So in the final answer also you will get just minus 2, not 1 by 2. So this is your answer. I hope you understood this question. Let's move ahead with the next one. So we are with question number 8 now. So the question is d cube plus 1 times y equals to e power x plus 1 the whole square. Now you're for finding the complementary function, you write this in the form of m. So m cube plus 1 equals to 0, a cube plus b cube, so a plus b, a square minus ab plus b square equals to 0. So from here you are getting m plus 1 equals to 0 and m square minus m plus 1 equals to 0. Using the quadratic formula here you are getting easily m equals to minus 1, and from here m equals to minus b, that is 1 plus minus under root b square. 1 minus 4 into 1. So this will, you will get minus 3 by 2. Okay, so you are getting m equals to 1 plus minus under root 3 iota divided by 2. Okay, so you are getting two values of m. Let's say that this as m1. So m2 you are getting as 1 plus root 3, 1 by 2 plus root 3 iota, and m3 you are getting as 1 by 2 minus root 3 by 2 iota. So if I were to write the complementary function, I will start off with this real and distinct one, which will give me c1 e power minus x. Then I will take my a here, so e power ax, so e power x by 2 I will get from here. Inside I will choose my b, so b here is root 3 by 2, so c2 cos root 3 by 2x plus c3 sin root 3 by 2x. Okay, so this is what I have for the complementary function. Now moving ahead with the particular integral. So particular integral is 1 upon f of d, which in this case is d cube plus 1, and this will be operating on this. I can write this as e power 2x plus 1 and plus e power x. I can separate, so 1 upon d cube plus 1 operating on e power 2x, 1 upon d cube plus 1 operating on 1, which can be written as e power 0x, plus 1 upon d cube plus 1 operating on e power x. So if you put 2 here, you will get 1 by 9 e power 2x, perfectly fine, no 0 in denominator. If you put 0 here, you will get 0 plus 1, which is 1. So this one is also 1 and 1 upon 1. So finally you are getting 1 here. If you put 1 here, you will get 1 plus 1, which is 2. So 1 by 2 e power x. Okay. So this was 1 upon d cube plus 1. We opened this bracket. So a square plus 2ab plus b square. So here you will get 2 also. So just taking that 2. So 2 by 2, that means you are finally getting a 1 here. So 1 is perfectly fine not to write. So y equals to cf plus pi. So c1 e power minus x plus e power x by 2, c2 cos root 3 by 2x plus c3 sin root 3 by 2x plus 1 by 9 e power 2x plus 1 plus e power x becomes your final answer. So let's start off with rule number 2, and this rule is for rule number 2 is for when q equals to sin ax or cos ax. For both you will use the same rule. So what was your equation looking like? It was looking like f of d into y equals to q. Okay, and you were taking particular integral like 1 upon f of d and whatever is with q. So let's take either we can take either sin x or cos ax. So sin ax is there. So what you will do in this particular case is replace d by minus of a square. Okay, and then you will simplify further. Okay, now again the main thing is, as long as denominator is becoming 0, you will multiply by 1x and differentiate. So that rule remains same. So you will write here f of minus a square doesn't needs to be 0. If it is 0, multiply by x and differentiate. Put the value here, again minus a square. So you will keep on continuing that step, okay? So that will be clear more from the question which we will take. So let's move ahead with our problem. I hope this was question number 9. If I'm wrong, then please correct me. So question number 9 is what I have in front of me. It says solve d square plus 4 times y equals to cos 2x. So first of all, converting it in terms of m square plus 4 equals to 0, m square equals to minus 4, m equals to plus minus 2 iota. Okay, fine. Now finding the complementary function, I can write this m1 as 0 plus 2 iota and m2 as 0 minus 2 iota. Gives my complementary function as e power 0x, which is 1, c1 cos bx, so cos 2x, plus c2 sin 2x. This becomes my complementary function in this particular case. Now finding for the particular integral. So for particular integral, you know what we will do. 1 upon f of d, which is d square plus 4, will be operating on RHS, which is cos 2x. Now here a is 2, so put 2 square with a negative sign. So if you square this, you will get 2 square, which is 4, and add a negative sign to it, so it is minus 4. So if you put minus 4 here, denominator is becoming 0. So what you will do, again the same basic concept, multiply by x, differentiate the denominator, so you will get 2d, and then put again, this will be 2d, okay? Now again in place of d, put minus of a square, which was your minus of 4, okay, operating on cos 2x. So you are getting x divided by minus 8 cos 2x. You can write this as minus x by 8 cos of 2x. Did we do anything wrong here? Yes, we have. So I have purposely done this to tell you that we have read earlier that d by dx needs to be replaced by capital D, d2 by dx square by d square. In the same way, if you get 1 upon d, that needs to be replaced by integral if required. Here what we did, since this was becoming 0 in denominator, so differentiated the denominator. So while differentiating the denominator, you would have got, let's see what we have got. If you differentiate the denominator, you will get 2d. Now look at here, I made a mistake here. Replace d square by minus a square. Okay, wherever you get d square, replace that by minus a square. Okay, not d. So if you replace d here, you don't have any d. So what you will do is to multiply numerator and denominator by d. So you will get something like this. In denominator you will get d square. Okay, so basic funda remains the same. Replace d square by minus of a square, not d. It was d square. So let's see what we are getting here. X remains as it is, d divided by 2 times of, if you replace d square by minus 4, cos 2x. Now you are getting x. I I can take this minus 8 out, so minus x by 8 and d of cos 2x. Now what is d means? D means simply d by dx, so minus x by 8. Derivative of cos 2x you all know is minus sine 2x, but because you are doing the derivative you will multiply by whatever is with x also, so you will get a 2 here, so minus minus plus 2 and this gets cancelled, so you are getting x sine 2x divided by 4 as your particular integral. So this was one approach. Some of you must be thinking that can I use this thing also? So once you have reached to this particular stage where you were left with what? Multiplying on x, you were left with 1 upon 2d, I reckon, cos 2x. You were left with this. So what we have done, operation will be done only on this portion because x is not an inside operator, x is outside. So you write x outside, this 2 can also be taken outside. 1 by d is same as integral, so you write integral of cos 2x dx. Now this is separate approach, you can use either of these. So x by 2 integral of cos 2x is sine 2x divided by the derivative of 2x, which is 2. So you're getting the same thing, x sine 2x divided by 4. So either of the two approach you can use, and we have found the particular integral, we have found the complementary function, so we can write the final answer as c1 cos 2x plus c2 sine 2x, and then the complementary function we have written the particular integral, which came out to be x sine 2x divided by 4. So I hope you understood this question. To basic funda was replace d square by minus of a square, okay, and use these things wherever necessary, and just as usual let's solve one more question after this. So moving to the next question, number 9. So we need to solve here d2y by dx square plus 3dy by dx plus 2y equals to 4 cos square x. First convert this in terms of d, so d2 plus 3d plus 2 times y equals to 4 cos square x. Now for finding the complementary function, write the auxiliary equation, which is m square plus 3m plus 2 equals to 0. So m square plus 2m plus m plus 2 equals to 0. M taking common, m plus 2 plus 1 if you take common, you will get m plus 2 equals to 0. You are getting m as minus 2 and 1. So you can write the complementary function as c1 e power minus 2x plus c2 e power x. Now coming to the basic important part, which is 4 cos square x. Using that you need to find the particular integral. So that will be 1 upon function of d, which is d square plus 3d plus 2. And here we'll have cos square x multiplied by 4. Okay. First of all, I take this 4 out because it's a constant. But I don't know the formula for cos square x. So I know that 1 plus cos 2x divided by 2 is giving me cos square x. So I can write this like that, 4 1 upon d square plus 3d plus 2. And in place of cos square x, I will write 1 plus cos 2x divided by 2. I can bring that out, and 4 by 2 is 2 only. Okay. Now I can separate. I can write this 2 out, and 1 upon d square plus 3d plus 2 times 1 plus and plus 2 times 1 upon d cube plus 3d plus 2 into cos of 2x. Okay. Now in this you can use that formula of e power 0x, that concept of e power 0x. So I can further write this as e power 0x. If I put 0 here, I will get 2. 2 by 2 is 1, and e power 0 is itself 1, so I will get 1 from here. Now here 2 square is 4 and minus of that, so minus 4. Put minus 4 here. But for that you need in terms of d square, because you will replace only d square by minus of 4. Okay. So what we can do is write this carefully. 1 upon, if I replace d square by minus 4, so minus 4 and d will be left plus 3d plus 2, and this is cos of 2x. So I will be getting here 1 plus 2 times minus 4d plus 3d minus d, so 1 upon 2 minus d is what I will be getting, and this is cos 2x. Okay. So let's look at this once again, how we proceeded with this. This was something like this. We converted cos square x as 1 plus cos 2x by 2, then separated with 1, separated with cos 2x. Okay. So this was our f of d, which I mistakenly wrote as d cube. So let's first dig into that. So this is d square. Now I will have to replace this d square. So this was error. So let's just remove this. If we replace this d square, it was clear that from here we are getting 1 2 times d square by minus 4, so minus 4 plus 2 minus 2, so 3d minus 2 is what we are getting, 3d minus 2, and operating on cos 2x. Now again we need d square to continue further, so what I am doing is multiplying and dividing by 3d plus 2. So 3d plus 2 and then 3d plus 2. So what this will do is I can write this as 1 plus, in numerator I will have 3d plus 2 divided by 9d square minus 4. 9d square minus 4 operating on cos 2x. So I will have 1 plus 3d plus 2 divided by, if I put 4 here with a negative sign, so minus 36 minus 4, this is minus 40 operating on cos 2x. Okay, so I will be having this 2 was also here. If we forgot this, we need to remember that this 2 is also here. So write this 2 with this, so a 2 here. Now 2 by this will give me minus 1 by 20. Now 3 times d of cos 2x plus 2 cos 2x. Okay, so this is 1. Okay, take 3 out, so minus 3 by 20 d of, that means derivative of cos 2x is minus sin 2x into 2. So minus minus plus cos sin 2x, so sin 2x. Okay, and this minus 2 and 20 gets cancelled, so minus 1 by 10 cos 2x is what I am getting. Now this gets cancelled, so 1 plus 3 by 10 sin 2x minus 1 by 10 cos 2x. So this is our final result for the particular integral, and we can write CF plus PI. So C1 e power minus 2x plus C2 e power x plus this thing. So 1 plus 3 by 10 sine 2x minus 1 by 10 cos 2x as our final answer. Okay. So we have done 10 questions till now, and let's continue with some more problems so that we get confidence. If there is some sort of a error in any of the question, you may do your own calculation, but the concept remains same, that replace d square by minus of a square. In some case, if you get 1 upon 3d minus 2 in denominator, multiply by the conjugate so that you get d square in denominator again to replace. Let's do one more question on this so that we get some confidence. So the question is solve d cube y by dx cube minus 3d square y by dx square plus 4 dy by dx minus 2y equals to e power x plus cos 2x. So I can write this as d cube minus 3d square plus 4d minus 2 times y equals to e power x plus cos 2x. Now this, for finding the complementary function, I will write this as m cube minus 3m square plus 4m minus 2 equated to 0. Is 1 a root of this? 1 minus 3 is minus 2, minus 2 is minus 4, and plus 4. Yes, 1 is a root, so simply write 1 here and the coefficients here. So 1 minus 3, 4 minus 2, write a 0 here, add, multiply, 1, add, multiply, so minus 2, 2, add in, and then multiplying, so you get finally a 0. So you get m square minus 2m plus 2 equals to 0. Using the quadratic formula, m equals to 2 plus minus under root 4 minus 8 by 2. So 2 plus minus 4 minus 8, that will give you minus of 4, come out as 2 iota divided by 2. So you'll get 1 plus minus iota. Okay. So 3 roots, you can write m1 as 1, m2, m3. So this is 1 plus iota and 1 minus iota. So the complementary function is c1 e power x plus e power x c2 cos x plus c3 sin x. Okay. So this is the complementary function coming out to the particular integral. So for particular integral, I have this, which is 1 upon d cube minus 3d square plus 4d minus 2 operating on e power x plus cos 2x. So obviously I will go for the separation. So d cube minus 3d square plus 4d minus 2 operating on e power x plus same operating on plus 4d minus 2 operating on cos of 2x. So I put 1 here, so obviously 1 was the root, so this will have to multiply by x and differentiate. So I will get 3d square minus 6d plus 4 e power x. If I put 2 here, since 2 was not the root of this, so this will be perfectly fine. Sorry, plus 1 upon if I put 2 here, so 8, and this will be 4, so 8 minus 12 is minus 4 minus 6 8 minus 6 is 2. So 1 upon 2 cos of 2x. And I treated e power x and cos 2x in the same way, which I did the mistake. So whenever you get cos 2x, which we are studying currently, you don't replace a, just put a here. You replace d square by minus of a square. So don't do that mistake. So if you replace d square by minus of 4, so 1 upon minus of 4d plus 12 you will get from here, okay, and plus 4d minus 2 operating on cos 2x. So you are getting let's see if we are facing any sort of difficulty. We have d cube minus 3d square plus 4d minus 2 and this gets cancelled. Fine. 12 minus 2 is 10, so you're getting 1 by 10 here. And here if you look at this, I have differentiated. Now if you I put 1, so I will get 3 minus 6, which is minus 3 plus 4, so 1. So x e power x from here, and 1 by 10, so cos 2x divided by 10 from here. Okay, so this is the particular integral, and this was the complementary function. Y you are getting as CF plus PI. Plus the pi, which is x e raised to power x plus cos 2x divided by 10. I hope you would be doing calculations on your own. Just the concept which we are using must be the same. Otherwise the calculations must be your own, so that if at all I am doing any error, you will be able to catch it and comment below. So this was all about this rule. Now we'll move further to another rule. So we have a rule number 3. When q is x raised to power m. So what was our equation? It is f of d to y. This was equal to q, and if q is equals to x power m, we will follow one approach. We will take the lowest degree term common from denominator. You write that lowest degree term common from denominator. Lowest power term common from denominator may be any power, but it needs to be lowest denominator, and then proceed. So you will get something like this. So you first of all, we write for particular integral, we generally use this 1 upon f of d into x raised to power m in this particular case. If you do all these things, lowest degree terms common, you might get something like this. 1 plus g of d, any function will be there in terms of d only, x power m. Might be something as also, but this was one of the examples which I am taking. And then you move this entire denominator towards the numerator. So you will get 1 plus g of d to power minus 1 x raised to power m. And then you use some binomial expansions, which I will be writing down. So concentrate. So if you are not getting clear with this, we will move ahead with questions, and it will be all clear. So let's look at the expansions first. 1 plus x power minus 1 is 1 minus x plus x square. minus x cube plus so on. Then we have 1 minus x power minus 1 is 1 plus x square plus x cube and so on. 1 plus x power minus 2 is 1 minus 2x plus 3x square minus 4x cube and so on. 1 plus x power positive 2. Now you must be knowing till now that 1 plus 2x 1 minus x raised to power minus 2. Okay, so in this case all positive, so 3x square plus 4x cube and so on. So there is a simple trick to remember this. If it is positive in the middle, alternate plus minus. If it is negative in the middle, all positive. These are the basic 4 expansion which we'll be using. Okay, so let's proceed with the problem parts. So the next question, numbering is not been even throughout this particular session. I have forgot some numbering, so make sure you don't take lot of mind into that. So solve d square minus d minus 6 plus d minus 6 times y equals to x. Now in right hand side you are getting x raised to power 1. First of all, find the complementary function which for which you need to write like this: m square plus m minus 6 equals to 0, m square plus 3m minus 2m. Taking m common, you are getting m plus 3, minus 2 common, you are getting m plus 3 equals to 0. So m equals to minus 3 and 2 is what you are getting. You can write the complementary function easily till now: c1 e power minus 3x plus c2 e power 2x. No problem whatsoever in that. Now moving on to the main part, which is the particular integral. So 1 upon f of d, which is d square plus d minus 6, and there we get x. Now what is the basic idea? Take the least degree term, which is 6 here, common in denominator. So minus 6 taking common, you are getting 1. If I write minus 6 in starting, and d square plus d divided by minus 6, or if you want to write that minus sign here, take a bracket common. Okay, and operating on x. Okay, now send everything to the numerator. So you will getting 1 minus d square plus d divided by 6 raised to power minus 1, and minus 1 by 6 waiting outside, operating on x. Now this is of the form 1 minus x raised to power minus 1. So what I told, if there is a minus in the between, 1 minus x raised to power minus 1, all positive. So 1 plus x square plus x cube. I don't think you don't need to write the entire expansion, but two first few terms. So this is minus 1 by 6. I am writing the expansion as 1 plus x, that is d square plus d divided by 6 plus x square. Now don't need to write terms above. Why? I will be telling you ahead. So this is it. Now minus 1 by 6 out, x multiplied by 1 is x only. Now d2 1 by 6 out of x, that means the double derivative of x, which is going to be 0 because the single derivative of x is 1, then double derivative is 0, plus d by plus 1 by 6 d of x. D of x means the first derivative of x, which is 1. Now coming here, d power 4 you will anyway neglect, because the fourth derivative is going to be 0. D square, you will at least write D square. So D square by 36. So 1 by 36 out of X. And then you will not write 2ab term also, because that will also give you a cube. So don't need to write further. This is it. Now multiplying minus 1 by 6 inside, this will give you 0, so no need to write this. Here you will get 1, so plus 1 by 6, okay, 1 by 36, sorry, and from here again you are getting 0. So this is what you will be getting. Minus 1 by 6, this term became 0, this became 0, minus 1 by 6 inside, you will get x by 6 here, sorry. So this is your particular integral. Now you all know y equals to cf plus pi. So what was your cf? Cf was c1 e power minus 3x plus c2 e power 2x plus pi, which is 1 by 36 minus x by 6. So this is the solution of this question. Easy one, just the expansion. If you liked some difficult, that was difficult, but again it was simple. 1 minus x raised to power minus x is minus 1 is 1 plus x square plus x cube plus x power 4 and so on. So question number 13 right in front of you. First of all, complementary function. For that we'll write this in form of m. So m cube plus 2m square plus 1 equals to 0. So converting this in terms of m, so m cube 2m square plus m equals to 0. First root hit and trial, so 1 will not be there. Minus 1 plus 2, that is 1 minus 1. Yes, minus 1 is one root. So this time I'll be solving this. Let's see by using the fraction normal division, long division. M cube plus 2m square plus m. Now multiplying by m square, you get m cube plus m square. So subtracting, you'll get cancel. Here you are getting m square plus m. Now multiplying by m, you will get m square plus m, which will get cancelled. Okay, now concentrate here. This first root you will have got minus 1. The other two root you can get from here. So m square plus m. So if you take m common, m plus 1 equals to 0. M equals to 0 and minus 1. So 1, minus 1, 0 and minus 1 are the roots. So I am rubbing this portion, so that because this question is going to be lengthy. So minus 1 and 0 are the three roots. So m equals to minus 1 and 0. Minus 1 and 0. Okay, so I can write the complementary function as c1 plus c2x e power minus x, okay, plus c3 e power 0x. So no need to write that. So this is the complementary function. Coming to the particular integral, for particular integral I write it like this: d cube plus 2d square plus d operating on e power 2x plus same operating on 2d square plus d operating on x square, and I am writing x square plus x with same, because anyway we need to differentiate ही करना है, तो कोई दिक्कत नहीं होना चाहिए यहाँ पे. अब ध्यान से देखें तो हमारे पास 2 है सॉल्व करने के लिए. तो यहाँ पे अगर 2 डालें तो कोई दिक्कत तो होना नहीं चाहिए, क्योंकि 8 और यहाँ पे 4 into 2, 8 16, and then we have a 2. So 1 upon 18 will be here, e raised to power 2x. If you come here, now again this is x power something. So what you will do is to take the least degree term common. So if you take the least degree term common from here, d will come out common. Inside you will get 1 plus d square plus 2d. Okay, x square plus x here. Now take this up. So e power 2x divided by 18 plus 1 by d. Taking this up, I can write this as 1 plus d square plus 2d raised to power minus 1 operating on x square plus x. Now 1 by d is basically integral. So whatever we'll get from here will integrate to solve this. So this is e power 2x divided by 18. Now 1 plus x raised to power minus 1. So 1 minus x plus x square, okay, minus x cube, something like that. So 1 upon d. So 1 minus x, so minus d square plus 2d plus x square, so plus d square plus 2d the whole square. Okay, now look at this. The first derivative will be 2x plus 1, second derivative will be 2, and the third derivative will be 0. So further we don't need to go. So write it till now here only, and with that we will have x square plus x on which we are operating. So this is e power 2x divided by 18 plus 1 by d. X square plus x came as it is. Double derivative. So first derivative is 2x plus 1. Second derivative is 2. So minus 2. And 2 times the first derivative. So minus 2 from here and minus 2 times. First derivative is 2x plus 1. D power 4 anyway neglected. 4d square is what we are looking for. So 4 double derivative. So double derivative here is 2. And again d cube we will be neglecting because that becomes 0. Okay. So e power 2x divided by 18 plus 1 by d, x square plus x minus 2 minus 4x minus 2 and plus 8. E power 2x divided by 18 plus 1 by d, x square minus 3x, and 8 minus 4 is 4. Now 1 by d, that means integration. So e power 2x divided by 18 plus integral of x square minus 3x plus 4 with respect to x. So this is e power 2x divided by 18 plus x cube by 3 minus 3x square by 2 plus 4x. This is your particular integral. And if you add with this your complementary function, which was c1 plus c2x multiplied by e power minus x plus c3. So this will become your, this was your particular integral, this portion. If you add this with the complementary function, you will get your final solution like this. Okay, so I hope you understood this question. Easy one, just the expansion which made it lengthy, and 1 by d wherever you see, that means you need to integrate whatever is inside that. Now coming to rule number 4, the final rule for the day If there are some more rules, we'll take that separately as a question, because this lecture is already become lengthy. Rule number 4 is, what was the format? F of d y equals to q. Now if q is e power ax into v, where v is function of x, so what to do in that particular case? Okay, so in that particular case, particular integral you write like this, 1 upon f of d, and here we have e power ax into v. Take e power ax out and replace d by d plus a. Keep the v inside. Whatever will be the v, either sine or in form of x power n or e power something only, then we'll proceed further. Okay, so this is the basic idea. Take e power ax out of this operator. Out means you will no longer operate e power ax now, because this is outside. This operator will now operate only on v. Okay, so let's move ahead with next question based on this, which is question number 14. We'll only do 2 questions on this. So this question is, solve d2y by dx square minus 2 dy by dx plus 2y equals to e power x cos x. So d square minus 2d plus 2 equals to e power x cos x. From here we are getting m square minus 2m plus 2 equals to 0. Okay, fine enough. Now okay, now if you use the quadratic formula, now m equals to 2 minus b plus minus under root b square 4 minus 4 into a, which is 1 into 2 divided by 2. So m equals to 2 plus minus 4 minus 8 is under root minus 4 divided by 2. So 2 comes out. So 2 plus minus 2 iota divided by 2, that means 1 plus minus iota. Okay, so your complementary function in this case will be e power x c1 cos x plus c2 sin x. Okay, so no problem in that portion. Now e power x cos x is our q in this particular question. E power x cos x is our q in this particular question. So let's see how to proceed with that. So I am telling the particular integral portion. So 1 upon f of d, which is here d square minus 2d plus 2, operating on e power x cos x. So here we have 1, so we will replace d by d plus 1. So and put this e power x out. D plus 1 whole square minus 2 times d plus 1 plus 2 operating on cos x. So e power x, this is d square plus 1 plus 2d minus 2d minus 2 plus 2 operating on cos x. So 2d gets cancelled, minus plus gets cancelled, you are getting e power x and 1 upon d square plus 1 operating on cos x. Now you all better know that cos x we have, so a is 1, so a square is 1, minus of that is minus 1. If you put, this will become 0. So what you do, multiply by 1x, take the derivative, which is 2d. Now this is not fine, so multiply this by d. Okay, in order to get d square again. Now replace this d square by minus 1. So x e power x. If you replace this by minus 1, you will get minus 1 by 2. So minus 1 by 2 outside d of cos x. D of cos x is minus sin x. So I am continuing with this now here. Minus x e power x by 2 and minus sin x. So here sin x. So this was your particular integral. This is your complementary function. Y equals to e power x. C1 cos x plus C2 sin x plus x e power x by 2 sin x is your final answer for this particular question. I hope you had no problem whatsoever in understanding this rule number 4. Let's wrap up this session with the last question. So we have the last question for the day, question number 15. Solve. Now the whole world of problem is open to you now. You can solve them, but this is the last question for the day. If you want any practice session, you can comment, or I will come with that in few months, weeks or days. So solve d square plus 2 times y equals to x square e power 3x. So m square plus 2 equals to 0, m square equals to minus 2, m equals to plus minus root 2 iota. So complementary function is here a is 0, so e power 0x is 1. Simply write c1 cos of root 2x plus c2 sine of root 2x. Now this was simple. Coming to that q portion, for finding the particular integral, I will write this as 1 upon d square by 2 operating on x square e power 3x. What you will do is in place of d, write d plus 3 and put this e power 3x outside. So d plus 3 whole square plus 2 now operating on x square. So e power 3x d square plus 6d plus 9 plus 2 operating on x square. So e power 3x 1 upon now a d square plus 6d plus 11 operating on x square. X power n, what you take, the lowest power term common, 1 plus d square plus 6d by 11 out operating on x square. Okay, so e power 3x by 11, what goes up is 1 plus d square plus 6d raised divided by 11 raised to power minus 1 operating on x square. 1 plus x raised to power minus 1. Okay, so 1 minus x plus x square plus x cube. So alternate plus minus will be there. So e power 3x divided by 11, 1 minus x, so minus of d square plus 6d by 11 plus x square, so plus d square plus 6d by 11 the whole square. No need to write further because first derivative is 2x, second derivative is 2 and third derivative is 0 operating on x square. So e power 3x divided by 11 x square, now minus 1 by 11, second derivative of x square, so 2x and is the first derivative, 2 is the second derivative, minus 6 by 11, first derivative 2x. Okay, neglect d power 4, neglect that 2ab portion, only 36 by 121 and the second derivative which is 2. Okay, fine. So e power 3x by 11 x square minus 2 by 11 minus 12x by 11 plus 72 by 121. Okay, so e power 3x by 11 x square as it is 72. Now taking this two term, LCM will be 121. So 20 minus 22 plus 72, that will be 50. Okay, so 50 by 121 minus 12x by 11. Okay, I hope this is it. So y equals to CF plus PY. So C1 cos root 2x plus C2 sine root 2x plus this thing. So that's it from my side. I hope you enjoyed this particular lecture, learned a lot, and will do problems at your home with yourself. Thanks and have a nice day.